Skipping 10.2, we're jumping right into 10.3. I believe this is a three section lesson. So 10.3 A, B, and C, because I need to break it down for you, especially since we're at the end of the year. Today we're going to look at 4 basic level operations with radicals. It's important you to get a grasp on these for today because our next lesson is going to look at a higher level of operation work. So how does this relate to variable operations? Well, in terms of the main 3 operations of addition, subtraction, and multiplication, your experience working with variables is useful. Be sure to listen to the connection so you can make the proper decision when the time comes. Before I get into addition, there is a note I had to make here which says explain simplifying a radical. This is something that goes off of the list of the notes, but I need you to make sure you write down because you have to have it for yourself. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. And so on and so forth. The key thing for you to remember from this list is the prime numbers. Prime numbers means they can only be divided by 1 in themselves, which means you want to memorize that group, this group, and that group. Now, you do also want to remember the square root of 121 is 11 because that's your next prime number, but that's not used a lot. Mainly, if you can remember the numbers 4, 9, 25, and 49, then you should be okay. And the reason you want to remember those is because those are the first 4 prime perfect squares. Again, 4, 9, 25, 49. When I get into class and I'm asking questions, I'm going to say the first 4 primes, first 4 squares, and you'll say 4, 9, 25, 49. The reason this helps is because whenever you get to numbers like the square root of 20, the square root of 20 doesn't have anything that is perfect. It's not a perfect number. But if you check the numbers 4, 9, 25, 49, does 4 go into the square root of 20? Yes, it does. It would be the square root of 4 times the square root of 5. Now notice how square root of 4 turns into a 2, and that becomes 2 root 5. And just for proof, if I were to type the square root of 20 into my calculator actually does it, but you have to make sure you learn it because it doesn't work for third roots. It doesn't work for roots that are too big, and it doesn't always work for you in general. You don't want to just rely on the calculator. The calculator will help, but you still need to understand why it's 2 root 5. Or if I gave you square root of, let's say, 75, you would look at it and say 4, nope, 9, nope, 25 goes into 75, so you would turn this into the square root of 25 times what, 3? Because 25 times 3 is 75. And so the square root of 25 turns into 5 root 3 because root 3 is not a perfect root, cannot come out. And check it out for yourself. Square root of 75 is 5 root 3. So that is the game that we'll be playing as I get to some of these tougher ones. Just again, make sure you're not cheating yourself by simply using the calculator or using some app to get the answer for you, because keep in mind, you're going to eventually have to be able to prove to somebody you know how to find it. And if you kind of cheat, quote unquote, cheat your way through it this time, then eventually somebody's going to say, well, show me how you got it. And then you're going to get exposed. At least have an idea on how to do it so that way you don't get caught up. But before we get to that, let's look at addition, subtraction in general. We learned a while ago we can only add or subtract like terms. So what that means is you can only put 4x and 8x together because they both have an x on it, and that it makes 12x. Just like you can subtract 5y minus 9y to get negative 4y. The same holds for adding and subtracting radicals. You can only add or subtract like radicals. Again, imagine this is like an x. That would be like 4x plus 7x because the root 5s are the same. And you can add them. That would be 4 root 5s and 7 root 5s, which makes 11 root 5s. You do not change that 5 into a 10, and that is why I used this as your example. We did not put 4x plus 12x equals 12, or 4x plus 8x equals 12x squared. We just put 12x. The label doesn't change. So therefore, 4 root 5, 7 root 5 makes 11 root 5 because the label doesn't change. 9 root 6 minus 14 root 6 would just be 9 minus 14, which is negative 5, and then leave your root 6. All right. Remember that I called our last lesson the foundation of our chapter. Let's look at the tricky level of work for addition and subtraction. So here we are, 5 root 8 plus 3 root 27 minus 6 root 75. And again, you should be trying to work these out without a calculator, but just remember that they would not give you this question if you couldn't do anything with it. So what I'm going to do is look at 5 root 8. and take it off to the side and say 4, 9, 25, 49. I believe 4 goes into 8. So this is 5 times root 4 times root 2, right? Because 4 times 2 makes 8. This turns into a 2, so it's actually 5 times 2 root 2, which makes 10 root 2. So that's what this actually is 10 root 2. 3 root 27, again, 3 root 27, I believe 9 goes into 27, so it'll be 3 times root 9 times root 20, I'm sorry, that'd be 9 times 3, right? So 9 times 3. That's going to turn into a 3. And as you get better, you won't really write the 3. You'll just say that turns into a 3, which is times 3, which makes 9 root 3. So plus 9 root 3. And then minus 6 root 75. Don't worry about the negative. I'll put that there. And then I'll go over here and do 6 root 75. 75 is 25 times 3. And again, that's going to turn into a 5. That's going to multiply by 6, making 30 root 3. So minus 30 root 3. Now you put your like terms together, as we like to say, but they're not like terms, they're like radicals. And the only two radicals that are the same are the 9 root 3 and the 30 root 3, which means leave your 10 root 2 the same. 9 minus 30 is negative 21 root 3. The reason I said don't use your calculator is because, again, it cheats you out of the learning process of what you need. I need the plus there. And I believe this will actually answer the question for you, which is why I recommended this calculator a very long time ago. Yep, negative 21 root 3 plus 10 root 2. So again, it does the work for you. But I don't say that to you so you can use it to cheat your way through it. I say that to you so you can actually check your answer and make sure it's right. Because the more independent you get without having to use your calculator, the stronger you're going to be. I can't think of one person who got up into the upper levels of math in my classes that was still needing a calculator to answer everything, because at some point, if you need a calculator to answer it, you're not going to make it. As long as you remember to rely on your understanding of variable work, it should be fine. Again, also make sure to practice well and ask as necessary. Multiplying also exists. So multiplying radicals is easy, but getting the correct answer can be challenging. Again, I know that sounds crazy, but consider the rule for multiplying radicals and write it down. It makes sense. Outside times outside, inside times inside. Just like when we did fractions, it's top times top, bottom times bottom. In other words, the outside value is found by multiplying the values that are already outside the radical, or any regular numbers. And the inside value is found by multiplying the value or values that are already inside. So consider our variable work. If we took 4 times 5x, we took the number times the number, which made 20, and we brought down our x. If we did this, there was only a 5, so we didn't change the 5, but we did do t times t, which made it t squared. In this case, numbers represent what we would consider outside, variables represent what we would consider inside, and so you would leave the regular number and just attach them as they are. And again, notice how we match the parts that belong. The same thing goes for our work with radicals. Unfortunately, your potential weakness with simplifying radicals could cause you to miss points. Let's just take a look at some examples and see what's going on with it. So 3 root 5 times 2 root 7. Again, outside, outside makes 6. Inside, inside makes 35. Do not forget to check. Does 4 go into 35? Nope. Does 9 go into 25 or 35? Nope. Does 25 go into 35? Nope. 49 is too big, so that is simplified. 4, 9, 25, 49. Check those numbers. Here, when you do 5 root 6 times root 10, the only outside number is 5, but 6 and 10 make 60. Does 4 go into 60? I think it does, because when you look at a clock, that's 60 minutes, and they break it into 4 sections, each section being 15 minutes. So 60, actually we can do it here, 5 is broken into 4 times 15. Again, if you need to know, just use your calculator. 60 divided by 4 is 15, which means that turns into a 2 and multiplies by 5 to make 10 root 15. Again, the nice thing is you can actually use your calculator to check it. Just type it exactly the way you see it and see that we do get 10 root 15 as our answer, just like you could have done over here. But again, don't cheat yourself out of the ability to learn it, because you do need to at least understand what's going on. 6 root 7, 2 root 7 turns into 6 times 2, which is 12. 7 times 7, which is 49. Isn't 49 a perfect number? So that actually turns into a 7, and 7 times 12 makes 84. Again, you can check that. 6 root 7 times 2 root 7. You don't really need to close it because it doesn't matter anyway, but there you go. There is your 84. The general rule is if you take a root times itself, you're going to end up with that number anyway, because 5 times 5 is 25, and the square root of 25 is 5. Square root of 10 times square root of 10 should just be 10, because 10 times 10 is 100, and the square root of 100 is 10. So the general rule you're going to learn eventually is that whenever you multiply a root by itself, it comes out. Anyway, that is not typically assessed directly, but again, the importance of what's going on should not be overlooked. The last basic level work comes in performing the distributive property. This is typically where your multiplication skill will be assessed, because where you actually do your multiplication is in problems like this. And you'll have to say this meets that. That will be your outside number is 3, 7 times 7 is 49, minus your outside number is 2, 7 times 5 is 35. Again, taking that 7 to here, 3 is your outside number, 7 times 7, 49. Taking it over here, 2 is your outside number, 7 times 5, 35. And you have to make sure you simplify. 49, think about it, 7 times 7 is a perfect number, which means that actually is 7. 7 times 3 makes 21, minus 2 root 35. So the difficulty with doing this is probably going to be similar to when you first started learning to add fractions, and you would say the answer is 6/8, and the teacher would mark it wrong, and you'd say why, and they'd say, well, because it's actually 3/4. Just expect that kind of frustration, but again, just learn from it, because the better you get at it, the less you're going to make mistakes on it, which is really what this is about. Same thing here, 2 root 6 times 3 minus 3 root 2, or sorry, root 3 minus 3 root 2. In this multiplication, think outside first. 2 is the only outside number, and 6 times 3 is 18. Minus, when you do this, the outside numbers are 2 and 3, which makes 6. My inside numbers are 6 and 2, which makes 12. Okay, 18. Check the numbers. 4. Actually, I should have done that, but I didn't have to. I know 4 doesn't go, 9 doesn't go, 25 doesn't go, and 49 is too big. But always check that number with those 4 that I told you. 4, no. 9 times 18, or 9 times 2 is 18. So this is actually 2, 9, 2. 9 turns into a 2, making 4 root 2. 4 goes into 12, so it actually be 6, 4 times 3. That actually turns into a 2, which multiplies by 6 to make 12 root 3. Again, if you want proof real fast, the nice thing about this calculator, which actually can be a bad thing if you use it wrong, is that this calculator actually gives you the answer that you need. And again, that is why I recommend this calculator, because if you're taking your ACT and you at least know the power that it has, then you can actually see for yourself that it gives you the answer you want. Negative 12 root 3, 6 root 2. Oh, I'm silly. 3 times 2 is 6. That's why it helps to have it to check. But yes, there you go. So outside of that, again, make sure you work to get this stuff finished. Make sure you work to understand it, and I will talk to you later. Good luck.